Let's start with the scene every data engineer has lived through. Your Spark job is at 95% and it's been at 95% for so long that your coffee went from hot to warm and to cool. The team says it's almost done. You say, no, it's stuck at, and I know why. In most real pipelines, this isn't a Sparky slow problem. This is a data skew problem where one task ends up doing most of the work. Hello everyone, welcome to Big Data Factory. In this video, we will do this like a production debug session. What a data skew is in 1 minute and how to catch it fast in Spark UI like a detective, and the fixes you can actually use in real jobs like AQE, adaptive query execution, and salting and repartitioning. By the end, you will know exactly what to try first and how to confirm it worked. So what a skew is actually? So in Spark runs in parallel by splitting data into partitions. Each partition becomes task. If partitions are balanced, task finish it around the same time. So data skew is when the distribution is not balanced. A few partitions become huge, then one or two tasks take forever and the entire stage waits. So this is like if you imagine you open 50 checkout counters in a supermarket and 90% of customers all choose counter number 1, you technically have parallelism, but you're still waiting behind counter 1. This is same as data skew. So I will use a data set and I will create one hotkey like hot. In real life, hotkeys are common, unknown, default, one popular product, one country, one customer. You get the idea. Once you have a hotkey, skew is not a possibility, it's a schedule. First, a quick sanity check, key distribution. If one key dominates massively, we already have a prime suspect. This doesn't replace Spark UI, but it's a fast way to confirm you are not imagining things. And yes, if you see one key with 90% of rows, that key is not a feature, that key is a future instant ticket. Now let's catch skew properly using Spark UI. Here is my fast method. Go to the slow stage, open task, sort by duration. If queue is present, you will see most tasks finish quickly, one or two tasks take way longer, and often they have much higher input record size or shuffle read and write. That's the smoking gun. The workload is not evenly distributed. This is why the job sits at 95%. The stage is basically done, except the one task that is carrying everyone else's responsibilities. So skew usually comes from 4 places. Skewed join key, like one key matches huge amounts of data. Skewed group by key, like one group is massive. Skewed files or partitions, uneven file sizes or bad partitioning upstream. Skew introduced after transformations like explode or filters. And here is a trap. People see slowness and add more executors. Sometimes that helps, but when it's skew, adding more executors is like hiring more cashiers while all customers still going to the counter 1. So we go to the fix number 1, AQE, adaptive query execution. If you are on Spark 3+, AQE can help Spark adapt the plan during runtime. In many environments, it may already be enabled, but don't assume, check it. My rule is simple. Try AQE first. It's the lowest effort and sometimes it resolves the issue immediately, especially for skewed joins. Then rerun and go back to Spark UI. If the task durations normalize, you are done. 2 lines, 1 protection fire avoided. We love that. And one quick myth buster. Myth, if I do repartition of 5000, skew disappears. Reality, you may have just paid for a bigger shuffle and skew is still there. Now you are slow and expensive. And we come to the fix 2, salting. So first, salting especially for skewed aggregations like group by. The idea is add a random salt, aggregate in 2 steps, combine the partial results. This splits the hotkey into multiple smaller pieces temporarily, so Spark can process it in parallel. This pattern is super common in production because it's predictable and it works. If your job was stuck at 95% because one key was massive, salting gives that key multiple checkout counters. And the fix for salting for joins. For joins, here is the professional rule. Do not salt everything, salt only the heavy keys. The production friendly approach is identify heavy keys, salt those keys on the big table, replicate the small table only for those keys, join on key comma salt. This keeps the extra cost limited to the part that actually needs it. Because if you salt everything, you might fix skew, but you will also create unnecessary data expansion and your cluster will remember that. Fix number 3, repartitioning, but with rules. Repartitioning triggers a shuffle, so you use it when you need better distribution, not as a reflex. Here are my rules. If you are about to do group by or join on a key, repartitioning by that key can help distribution. But if the key itself is skewed, repartitioning alone won't magically fix it. You still need AQE or sorting. If you are reducing partitions near the end, prefer coalesce to avoid an extra shuffle. Repartitioning is a tool, not a prayer. So here is the cheat sheet I use. Join skew and then try AQE first. If still skewed, salt heavy keys. Consider broadcast if the dimension table is small enough. And 2. Group by skew. Use salted aggregation. And number 3. File or partition skew. Then fix upstream using compaction or partition strategy. Avoid uneven files. And if you are not sure, go to Spark UI and then see task, sort by duration, and then compare input or shuffle metrics. If you do this consistently, you will debug skew in minutes, not hours. If your Spark job is stuck at 95% today, open Spark UI, go to task, sort by duration, and you will immediately know if skew is the reason. So this is all for today, and if this video helped you understand data skew clearly, please do like, share, and subscribe to my YouTube channel, and comment skew and tell me what caused your issue, either join or group by or write, and I will make a follow-up with more real cases.